Hello, calculus fans! All right, let's try to find all values of x so that the power series, where we're summing n goes from 1 to infinity, of minus 1 to the n over 4 to the n times n, all multiplied by x plus 3 quantity to the nth power, converges. Now, the usual method of answering a question like this is to apply the ratio test. So we're going to put everything into the ratio test. This looks like a big mess, right? We have to take the terms of our power series, replace the n with n plus 1, and that's what we have here. And then we also divide by a sub n, so that's what we get here. Now, the first step is always the messiest, then we do a bunch of cleanup. Okay, so let's see what happened here. First of all, the minus 1s just got canceled out because of the absolute value. Then we had 4 to the n over 4 to the n plus 1 turn into 1/4. Let's see, then we've got n over n plus 1 turning, not really changing in anything, but just moving it around. And finally, we've got the x plus 3 to the n plus 1 over x plus 3 to the n turning into absolute value of x plus 3. Now we have to keep the absolute value on that because we don't know if that's positive or negative. Whew, what a mess. Okay, now we're going to bring the absolute value of x plus 3 outside the limit because the limit is as n goes to infinity, so that's not affected by, that does not affect the absolute value of x plus 3. Now this limit here just turns into 1/4. Leading terms, right? Now we want what we got here, 1/4 absolute value of x plus 3, to be less than 1. Why is that? Remember, we're using the ratio test. All right, let's solve for x. All right, so we take this inequality, multiply both sides by 4, and then we remove the absolute value. And so when you remove the absolute value, it turns into a compound inequality. And then we can subtract 3 from both sides. So we can say that this series definitely converges when negative 7 is less than x is less than 1, and that's according to the ratio test. The thing is, if we look specifically at x equals negative 7 or x equals 1, the ratio test is going to be inconclusive. And so we need to test those separately. We're going to go ahead and do that now. I should point out that when we do those tests, those separate tests, we have to pick something other than the ratio test. The ratio test is going to be inconclusive at those points. That's worth remembering. All right, so let's see what happens at x equals negative 7. Our series looks like this when we plug in the negative 7 in. And so now we're going to get the sum of negative 1 to the n minus 4 to the n all over 4 to the n times n. And most everything cancels here. Like all of this, that's just 1. So we're just left with the sum of 1 over n. And does that series converge or diverge? Remember that that's the harmonic series. We proved directly that it diverges. If you wanted to, you could also say it's a p series with p equals 1. How about when x is equal to 1? Now our series looks like this, which turns into this guy. So now the 4 to the n's are going to cancel, and we're left with the sum of minus 1 to the n over n. That converges by the alternating series test. The b sub n's, which is 1 over n, that decreases to 0. So our final answer then is that the power series that we started with converges on the interval from minus 7 to 1, including 1 but not including minus 7. We're writing down where this power series converges. Okay, that's all for now.